Hello, and welcome to the Topic In Depth series, episode 2 on indices, which is kindly supported by Tez. I'm here, as always, with Jo Morgan. Hello, Jo.
Hi, Craig.
Now, Jo, opening question, why are we doing indices today?
Oh, isn't that the best topic? I absolutely love indices. It's not just that I love it, it's also pretty fundamental to so much of maths, and actually they meet it a little bit in primary, but we do a lot of it in very early secondary, and then it just goes right the way through. You can't do A-level without good indices knowledge. So, and it's so fun, and it's so easy to explain, which we'll come to later. But there's so many lovely things about indices.
Right, I'm coming into this a bit of an indices skeptic, so I'm ready to be persuaded. Just a little note for our listeners, all of the resources that Jo's going to talk about are available to download the PowerPoint that goes with this video from Jo's website. So don't worry about noting things down as you go. Right, what are we starting with then?
Right, well, if we're teaching any topic, we need to think about some sort of standard stuff. And let's say we're teaching, it doesn't have to be indices, any topic coming up, and we're in a department meeting and we're talking about how we're going to plan this topic. Let's say that the first thing we think about is the progression of that topic. Okay. So where does it go from key stage 1 right through to key stage 5? Okay. And we talk about that with any topic.
And I'll tell you now, I don't do that enough. Because I'm just, right, we're doing this for a year now, what's it saying, the scheme of work? I don't do enough thinking of where it's come from, and I definitely don't do enough thinking about where it's going.
And you ask a teacher who's teaching fractions in year 7 if they've done fraction division before, and some of them will not know. So we really should know what's going on in primary. But also the links to other subjects, other parts, are they seeing indices elsewhere? I mean, we know they're seeing standard form in science. Yeah, are true. They, the prerequisites, all that kind of thing. So we should think about that for any topic. Okay. The examples we're going to use and the explanations, that's the most important thing a teacher can think about. Absolutely key to being a teacher is how we're going to explain it. How are we going to assess students? Like, how are we going to know whether they've got it? How are we going to know where they're starting? How are we going to know how they're getting on while we're teaching? All that kind of thing. What are their misconceptions? So what is it that they are going to get wrong here? Yes. We have to know that. That's part of our subject knowledge. What tasks can we use? What resources we can use? How are we going to develop fluency? How are we going to challenge our students? How can we support our students? Yes. Where's the enrichment? Where's the narrative? Are there stories to tell here? Is there anything that really interesting that we can talk about that's just they're really going to remember and they're going to go home talking about this really fascinating thing they learned in maths today? And overall, for any topic, how can we teach it in depth and not at this kind of superficial level? So how can we sort of go into a level of depth where we're filling our lessons with valuable, useful things and not rushing through things?
That's if I was to do a slide for my first 12 years of teaching about how I'm planning my topics, I just need one box and it would just say, find a nice fancy resource. And that'd be it, right?
Yeah, it's sad, isn't it?
But it's interesting that you say the most important thing is explanations and examples. I completely agree. Yes. It's the examples we give our kids and the explanations that illustrate those that are going to help shape their understanding and experience of a topic. And I'm certainly guilty of not putting enough thought into that.
So I think any topic we're teaching, this is what we should be talking about at department meetings. We should be either thinking about these things on our own or collaborating on our ideas for these things for any topic.
I'm on board.
So if we do this for indices and we start by looking at that progression, it's actually fairly late in primary that they first meet index notation, and it is just squared and cubed. Okay. So they are seeing that notation. It's not like they've never seen it before. Yes. But it isn't a massive deal.
No square roots and cube roots. It's just squares and cubes.
So just these and they're and if you look, it's talking about. It's kind of just mentioned in this thing about solve problems involving multiplications and there's squares and cubes and that, and it does come up on SATs. So the fact it comes up on SATs means we know this is definitely being taught, and actually if you ask year 7s coming in, they have seen it before. Yes. That's the sort of question they'll get on their SATs. So 3 squared plus 10. So they do have to know what the little number does. Yes. That's another question. A square number and a prime number have a total of 22. It's a bit more problem solving. And that means they need to know what square numbers are. So it's not just that they need to know what the little 2 means, but they need to know what their square numbers are, and maybe they've spent some time looking at squares and primes. Okay, kind of okay. So that's kind of the extent of it at primary school, which actually I really love that if I'm teaching year 7, I get to teach something that they've not seen much of before, because it's got that real secondary school freshness about it, and that sort of exciting, let's look at a new topic.
But it is important to be aware that, as you say, not everything's new to them, right? So those little numbers, if I come in saying, wait till you see this.
No, don't do that. Yeah.
Already seen that, sir.
I'd always start with the, so you would have seen this before. I know you've seen it before. Let's see if we can remember what that does, and let me go into a lot more depth on it. Nice. At Key Stage 3, we've got recognising powers of 2, 3, 4 and 5.
Wow.
So that kind of surprised me when I saw that explicitly written. And also we've got where algebra comes in. So knowing that a squared is a times a, etc.
It's worryingly vague, that as well, and it just how many powers you need to know of 4 and 5 and stuff. Yeah,
absolutely, yeah, because I think it's actually defined at GCSE. I think we know what we go up to.
Okay.
Certainly we know what we have to go up to 15 squared, for example, for square numbers.
Yes.
Like that's all defined. But yeah, that is very vague.
Yeah.
And then we have stuff on roots in there as well. And then at GCSE we have index laws. And I notice that index laws isn't mentioned at Key Stage 3, but we all teach index laws at Key Stage 3.
Yes.
But it's not mentioned there. It is mentioned at GCSE, and also that's where our integer and our fractional indices are coming in for the first time.
Got it.
So that's really all that. It's all very vague and all very sort of no detail.
And you can imagine, right, like if you're a new teacher reading this, you think, what the flipping heck's going on here?
Yeah.
How far do I take it? And so on. It can be really hard to follow. Just specifications just like this,
that's
right?
why, say, for example, AQA's teaching guidance has the example questions in a
so
lot more
important,
detail.
so
yeah, you can't, from that, you've no idea what you're meant to be teaching. Yeah. And it comes up a lot on GCSE, as you'd expect. Typical, this is an AQA foundation question, so that's 2017. Standard, that is as standard as it gets for indices.
1 mark.
And that is just testing, do you know what that notation is, and can you multiply 2 by itself 4 times?
Yeah.
Another standard multiple choice question, which one does not simplify to y cubed?
It's nice. That's harder though, right?
They're going to get some of those wrong.
Because it's your classic example, non-example.
And you've got
thing.
those y to the power of 1s in there, which in fact in 2 of those questions. And actually the fact they've gone for 6 and 2 in the last example when 2 is a factor of 6, and because we know that the choice of numbers, when you do the division law, the choice of numbers makes a big difference about whether they'll get it right or wrong.
Absolutely.
So that's quite tough. That's foundation. But it is, this is index laws there.
What do you reckon most common wrong answer there would be?
Most common wrong answer.
I'm going for the y to the power of 2 times y, I reckon. I reckon it could go wrong there, maybe.
I don't know. I think maybe the y to the power of 4
divided by y, possibly.
I don't know. I think I'd be interested to look at the stats for that. But
worth asking to the kids, though, that one, isn't it?
Yeah, it's nice.
Definitely.
Yeah. And then we know that it comes up in other topics as well. So standard form, you need to know your index laws. If it's a non-calculator standard form question, you need to know your index laws. And things like that. Factorising. It's just algebra. Yeah. And you don't need to know index laws, but you need to know what a squared means.
Yes.
So you need to know what index notation is.
Yes.
Simplify m cubed plus m cubed. Now, they're all going to go wrong with that.
Of course they are.
Because they're going to think that's an index laws question, and it's not. It's a simplifying algebra question. But again, we've got index notation all over the place.
Yep.
Write 36 as a product of prime factors and give your answer in index form. So again, they need to know what index form is.
Just sorry to interrupt, Joe. It's interesting in the index form. It goes right across number and right across algebra.
It does, yeah. It's very much. It's one of those topics where if you're trying to create a website like mine, and you don't know where to put indices because it comes up in both. On higher, you can get some pretty challenging questions. In fact, some of the hardest questions on the paper often involve index laws. That I think is fairly standard. Now, I don't think that one's too bad.
Looks bad though, right?
I think a year 7 who's done a year 8 who's done index laws can do that.
Okay.
I don't think you need to be like a higher end year 11 to do that.
I think it shows you that kids need to be comfortable with things expressed with letters as opposed to just doing the number examples. I think it looks worse than it is.
Yeah,
you're
right.
Question.
It does.
Nice question.
And then that's sort of standard testing of negative and fractional indices, but they do find that hard. Yes. And I think that is really learn the rule and you've got it, but they do find that harder than I expect.
Yep.
But to me, the really hard GCSE questions on this is your change of base questions. Yeah. And that's the one that would tend to be the last question on a paper and really low numbers getting that right.
Yes.
I normally teach change of base at GCSE. I normally teach it in year 10, but this year I had to do it with year 8, and they just weren't ready for it. It's such a complex topic. There's a lot going on in that.
And it interleaves in other stuff as well. You see straight away all your fraction rules are in there. Hard stuff.
So that is kind of as hard as index laws or indices gets on GCSE. Change of base is kind of the most difficult, the highest level that you get. Writing things as a power of 2, there's an issue there where my students, when I've had a sort of top set year 11 before, and they've all been getting grade 8 and 9, and they've come out of the exam and they've said, I didn't know what that meant by a power of 2. And that was a failing in my teaching where I hadn't really spent time talking about powers of 2 and what that wording means. So they may have been able to do the maths if they'd known that I'm talking about a base of 2 there.
That's interesting.
Yeah.
Okay.
So that's kind of as hard as it gets. But then we all know that it goes on to A-level as well, which I'll talk to you about in a minute. This question, which wasn't an end of the paper question, it was kind of 2/3 of the way through. This one, my top set year 11 really struggled with. So have a look at it. N is a number, and then we've got n written as a product of primes, but it's got that. It's a bit unusual, and then we just have to write out 3n squared. All we're doing is taking that expression. And we have to know our order of operations. So we have to know that we are squaring it and then multiplying it by 3. So first of all, we're squaring it. So we think about what happens to the indices. And then we multiply it by 3, which is just changing the power of 3. That's really tricky.
I think that's very hard, that, you know.
So I think, so even though I've talked about these being kind of the hardest, as hard as it gets, I'd say that was a pretty hard index question.
And now we're talking about teaching indices in depth for this series. That's kind of the ultimate aim, right? You want kids to be able to, all the questions that you've seen, you want them to not have learned some method to do it, but because of the unpredictability of these questions, they need that deep knowledge to not be like, what the hell is that? That's the thing. If they're thrown by this because they've never seen one like this before, then I haven't taught it in depth enough, because they shouldn't be thrown by unfamiliar questions. I mean, that's the aim, isn't it? That they're not thrown by unfamiliar Absolutely
ones.
Right.
At A-level, and I just thought I'd show one example. The content on the spec says understand and use the law of indices for rational exponents, and it's given. They should know index laws, and we always do a little bit at the very beginning, but they should know it, particularly those fractional and negative indices. And if you look at part A here, they are taking that expression and they're writing it with indices in order to differentiate it. So you just cannot do A-level without a very strong indices knowledge. It's absolutely prerequisite and standard.
And it's one of those things, the worry is you can get through GCSE without knowing it all that much. You can get a very good grade without, and then you come to A-level and you're in a bit of trouble.
Absolutely. And you know, we haven't got time to teach it in depth at the beginning of A-level, so they really need to come in knowing this.
But we're doing it in depth now, aren't we, Jo?
So we can't do it in depth at the beginning of A-level, but we can do it at depth lower down the score.
Nice.
So if we start by looking at index notation, and this is where I have not done this well in the past. I have been far too quick. So this is how I used to do it.
Okay.
I'm so sorry about this. So I would say, I get my sort of year 7s and say the lesson would be not a lesson on indices, but a lesson on multiplying terms algebraically.
Okay.
So the first time we're doing algebra with year 7, and I get to that point where, say we might have done a bit of simplifying, and then now I want them to do A times A. Right. And I'm thinking, right, this is where I'm going to have to bring in the indices. Nice. Now I do an index notation lesson kind of, and it needs to come before my multiplying terms lesson.
Right,
but here I'd say, right, we're doing multiplying terms today, so I'm just going to check they know this. Right. So I say, right, you all know what this means, don't you? And then one person will put up their hand and say, yeah, that means 2 times 2, because that little 2 there means squared. And I say, yeah, so you all know this because that one person answered. And I'd say, oh, so what do we think this one means? And then obviously one person would answer. I'd say, yeah, you've all got that. Yeah. And then I might say, well, I think you've seen this one before. I think you've seen this at primary, so who knows what this one means? And again, someone might say it's 2 times 2 times 2, and that one person replying would be good enough for me.
And I'll tell you what, it's not just good enough for you. So Dylan William says the greatest mistake he made as a teacher was assuming whole classes' knowledge based on the response of 1 or 2 confident students. It's
absolutely.
So easy to do.
Yeah.
It's so
and
easy
even
to
if
do.
even if you cold call and you pick that student, it's still not telling you anything.
Absolutely right.
And then I might say, right, we've not seen this one before, so can we guess what this one is? And hey, then let's guess what this one is. And now we know index notation, and let's move on with our multiplying terms. So that was how I used to teach it.
And it's interesting as well, because you've got the issue with 2 squared, your classic ambiguous problem, isn't it? Because you get it for...
You've got a 2 and a 2 there.
Four's the answer, but you don't know whether they've got the misconception or not. Yeah, I've been there, Jo. I've been there.
So, and now I'm much more explicit with my teaching of powers, and I start with, and I've got this thing now which is controversial. This is controversial stuff.
Come on.
Because the whole thing's a power. And for about the last 50 years, we've been calling the index a power.
I'm still calling it.
Well, yeah, you need to stop that right now.
So what's this? So the whole thing is a power?
The whole thing's a power. This is the fourth
power of 2. So it's not 2 to the power 4?
We can say that, yeah, 2 to the power 4. That's how we say it. 2 to the power 4. But that little number is not a power. 2 to the power 4 is a power. Yeah, this is the fourth power of 2. This thing here is the fourth power of 2.
Okay.
These are powers of 2. They have a base of 2. They're powers. The whole thing's a power. And I've made the mistake of, and so does most of the country.
Okay.
Let's say 99% of teachers do this.
Okay.
Because textbooks do it as well.
And
we say, hey, see that little number up there? We can call that an index. We can call it a power. Or maybe we'll call it an exponent occasionally, but probably not because we're not American and we might do that A-level, that kind of thing.
But index is the only... Exponent's fine.
Index and exponent are fine. And
index,
you know what? Call it power. If you've been calling it power for years, keep calling it power. It's no one's going to die. It's not the end of the world. It's not a power. And if you and at some point, I've researched this through lots and lots of old textbooks going back hundreds of years. At some point, someone started calling it a power. Everyone else started calling it a power. And we now kind of get it a bit wrong.
That's interesting.
Okay, it's an index. And actually, you know what? I had some tweets from some Americans who are saying, why are we calling that an index? Because an index to them is the little number on a radical. So let's say you're doing the cube root and you've got the little, that's an index. That's the index of the radical or the root.
Wow.
And actually, for us to call that an index, they think is massively confusing. And they're like, why aren't you calling it an exponent? So the language isn't straightforward, as in everything.
That base is an interesting one as well, right? Because that if you don't start mentioning this here, when the kids get to A-level and they're starting to learn logarithms and stuff, you can really throw them that if base is a new concept.
And I think bases are nice because we know that the base is at the bottom.
Yeah, I like base.
So base is a nice word because it makes total logical sense to us. Okay. So I taught this recently to my year 8s, and this was my opening slide. So we pulled the vocabulary apart. Okay. They drew it in their book, and we have that nice diagram, and some of them labelled it wrong and did that little line going in, and it's like, no, the whole thing is the power. Sure. And then so here's the powers of 2. These are powers. So let's not call the little numbers powers. These are the powers. Okay. The first power of 2, the second power of 2, the third power of 2. Okay. It's a bit confusing because if I had 2 to the power of x, then I want to say that's the x power of 2, and that's a bit of a mouthful, but this is what these things are. So if we say, and these are actual slides I use with students. Okay. I say, right, we're gonna just have a little look at that fourth power of 2. We're gonna zoom in on that one, just spend a bit of time on that, and then I'll give them that label again, and I'll say this is the index, and I'll say this is the fourth power of 2, and I'll say, how are we gonna say this out loud? And there's actually loads of ways of saying it, and just bear with me on this because there is a ridiculous amount of ways of saying this. Not all in the English language.
I've seen a couple of dodgy ones.
Well, 2 high 4.
2 high 4.
I'm going to be honest. I just put that in because I thought it was funny. In German, they say zwei hoch 4, which means literally 2 high 4. And I thought that is a much cleverer way of saying it than how we say it.
2 high 4.
It's a high 4. It's good, isn't it? And that's the only one that's not an English language one because I translated it. The rest of them are genuinely ways that are said.
2 at the power 4. Is that one? Who's saying that?
People. Tweeted
Who are you hanging around with?
People tweet. I asked how people say it on Twitter. These were the responses. Not necessarily from this country, but I say 2 to the power of 4. Yep. A lot of teachers say 2 to the power 4. Some teachers say 2 to the 4th. I don't mind 2 to the 4, and that's pretty common. What I do not tolerate is 2 4.
No one's saying 2-4. 2-4?
Students are saying 2-4 and not being corrected on it. And that makes me cross.
2-4's bad.
If a student says 2-4, I'm like, whoa. Step
2-4 is almost as bad
say
as
that again.
2 high 4. So, okay.
But all the other ones, I say 2 to the power of 4, but I've certainly got colleagues who say 2 to the 4, and that's okay.
Yeah, I've done 2 to the 4.
But what I say to my students is, hey, we're all going to say it the way I say it because I'm going to be saying it like that, and I don't want this inconsistency. And then I actually did do some choral response with this with my year 8s recently. So I had a load of them on the board, and we did some choral response, but also I did a thing where I had 30 of them on the board, and every single person had to say one out loud. But I included some squared and cubed in there because that's where the rule breaks.
Yes.
Because I don't mind them saying 2 to the power 2, but I prefer them to say 2 squared. So I had a mixture of them on the board where they were saying 2 to the power of 8, and then the next one might be 2 cubed. So I was, sort of throwing in that kind of. There is an exception to this.
I'll tell you where 2 to the 4th breaks down a bit. That's as soon as you start getting into fractional.
Yes, you're right. Yeah,
you're in a bit of trouble there, aren't you?
Yeah. So 2 to the power of thing works for anything.
I'm happy with that.
So this was interesting. I just wanted to mention this because I spotted it the other day. This is TJ, which is a Scottish textbook. Okay. And I don't know TJ well. No. But I'd never seen this before. What? The smaller number on the right shoulder.
Oh my God.
Now. That's really interesting. And they've called it an index or a power. That's common. So I'm saying it's not a power, but all textbooks do that. But I've never seen it called a shoulder before. And I don't know if that's just in TJ or if that is a common thing.
And I'm interested with the right shoulder. So is that implying there's a left shoulder?
That's interesting. Yeah, there is nothing on the left shoulder. Yeah. But the word shoulder really confused me there. But I do think it's worth talking about indices and index and the plural, and specifically talking about what we mean by a plural.
Yes.
And then notice here they've then gone on to calculators, and I will talk about that later, but there is so much to do on calculators here. Okay. It's a lovely topic for calculators. But in terms of language, there's all sorts going on here. And just being really clear with how you want your students to say it and correcting them if they say it wrong. If they say 2-4, I'm correcting them every time.
And it's interesting. You love a bit of etymology of words, don't you? And it's also interesting to show kids the different ways that it's said around the world and stuff. It's a very valid thing to do.
They find it really interesting.
Piques their interest, and it's memorable for them and stuff as well.
When I talk about narrative and enrichment, that's the kind of thing I'm talking about. Yes. So when I talk about kind of having a bit of narrative in the maths lessons, it's when I sit down and I kind of perch on the edge of the desk and I do let me tell you what they do in America, and they're thinking, wow, Miss knows a lot about maths. It's that kind of thing, which is like, that's the narrative where I'm just, I know you're obsessed with time in lessons and using time carefully.
Correct.
And I think that it's a good use of time to have a bit of narrative, and that's debatable, I think. So then I might say, well, we've looked at the powers of 2, now let's look at the powers of A.
Yes.
So it's the first power of A, the second power of A, the third power of A, and it works in the same way as the powers of 2. And then this is genuinely a slide from my lessons. I talk about Descartes, and he wrote in his book, in the kind of the appendix in his book, he did a load of notation stuff where he basically introduced a lot of our modern notation. And there it is in French, and we actually look at it in French. They don't speak French. I can understand a bit of this. That end of the first line, and A or A squared to multiply A by itself.
Nice.
And so I've got the translation there. We don't speak French there. Yeah. So I didn't actually say it in French there because my accent is not good. But the idea is that he's saying, and thus to infinity. And he here is for the first time ever introducing index notation. It had never been seen before, and we have now used that, and that was 1637. It is standard in our mathematical lives
and
now.
Kids love little tidbits like, again, and even if you're not that interested, it's 30 seconds of time, but for the ones who that resonates with, that's lovely.
Really, exactly, it's not a lot of time, and I like to think, I also do, does anyone know anything about Descartes? And we talk about I think therefore I am, but I don't know much about the philosophy, but I would like to kind of go down these routes a bit more.
We'll do philosophy in depth next year, Jo, once we box this off.
Once I've done the Descartes bit, then now this is an exercise from Rayner, which was a great textbook from the 90s. And this is just, this is introduction to, and notice how we're using a calculator, because there is no harm in using a calculator here. We're so quick to say to our students, no, indices is a non-calculator topic, but there's no harm in using it here. We're getting to fill in the table. So in the first one, we say 2 to the power 4. We write, and then we've got that notation. We work out this, and from our calculator, we can get the answer, because I'm not going to have them waste time working things out here.
Yes.
So we can go through and fill that in and notice the gaps. It's a bit like filling in the gaps where the gaps are in different places.
The calculator point, I know you're going to come on to this later, but it's an interesting one to address very quickly here, that I think a mistake I've made, I don't know if it's the same with you, Jo, is I've reserved calculator use for the so-called calculator topics, whether it's trigonometry or solving quadratic equations. But kids aren't good at using calculators, are they? Yeah, and often listeners probably seen this themselves. You'll get kids, and it's particularly the lower achieving kids on foundation. It's a foundation calculator paper, and they're not using the calculator for some, and it just does my head in.
Yes, it's a really common problem. It's something I'm really working hard on at the moment. So my recent conference presentations have been on how to solve that problem, because we're in a bit of a mess with it. They got rid of calculators at primary, and then suddenly we've got generations of kids who are barely using calculators in Key Stage 3, because we're saying, no, you need to practice your arithmetic all the time. It's like, no, they don't. They need to also practice their calculator a lot. So we need to chill out a bit on the no calculators here. There's plenty of opportunities to use calculators and indices.
I like it.
This was from a textbook from Tajikistan. Apologies if I'm saying that wrong. And that is writing index notation. Now look at the difference. This was from Rayner, and it's just numbers.
Yes.
Whereas here they're saying, well, that first one is 5 to the power of 5. And then we've got a quarter to the power of whatever that is, 7 or something.
Yes.
And then look, that says 6 14 times. So it's 6 to the power of 14.
Yes.
And then we've got a negative x to the power of 25. And this looks like a killer, and it's really not, because it's just index notation. And why not use non-integer bases?
Yeah, absolutely. And again, it's interleaving, it's getting kids familiar with things.
Exactly.
And it's not getting them in that fixed mindset that indices is just number related at this stage. I love it.
So yeah, I mean, I took that idea and I created this resource, which I've used a couple of times now, and it always works really well, where it's similar to the Rainer thing, but also bringing ideas from that other one, where I'm saying the first few they're fine on, and actually the thing that kind of throws them is that there's brackets. I have to talk about the brackets. I have to talk about why did I put, if you look sort of 2/3 of the way down the left hand side, why did I do -3 to power 4, and why did I put my -3 in a bracket? So just having that little conversation about why I've chosen to use brackets there is actually a really useful conversation.
Do you know a couple of my favourite questions on there, Joe, straight away? I love the power of ones there. I love the 5 to the power of 1 and the 9xy to the power of 1, because that's the ones that throws kids, right? It's those boundary examples that are so obvious to us. Well, of course it's the same, but unless you explicitly confront kids with that, we don't know if they know it.
I'll tell you where they totally can't do this. But bear in mind, they haven't done index laws. This is notation. The one on the right hand side, nearest the bottom, and it's 9a to the power 7 times 9a to the power 7. That's where the very best students, they get stuck there. They put their hand up at that point. And it's just 9a to the power 7 squared. That's all I'm looking for there. I've got something times something. And we're saying, well, something times something is that thing squared. And it's that one totally throws them, even though just above it we had the 7ab and they were fine with that. And it's because there's that index in there. And they've not seen that before. So, I mean, it's quite, these activities are so revealing in terms of things I haven't thought to address with them.
And it goes back to what you said at the start, why it's so the examples and explanations we choose are so important for understanding. Lovely, Joe.
This is from a Victorian textbook from the 1800s.
You love an old textbook.
I do, and the thing is, it's worth looking at how did they do this back then? What order did they do it in? And here it's so similar to what we do now. They're saying write these in simplest form. They're saying write it in index notation. So we've got a b times b, and they have to write b squared. Notice how they get rid of the multiplication signs about halfway down. So we're looking for e. Which is we don't need those multiplication signs in there, and then we've got some combinations, like we've got e f, so they're writing e squared f to the power 4. This is nothing but notation. We are not on index laws yet. We are just looking at notation. These days, and then that was the first part. That was a page long. These days we have the same, but we can get 6 questions in the textbook. So it's just a difference in volume. We're actually asking really similar stuff these days, but there we had, I don't know, maybe 50 questions, and now we have 6 questions.
And I like the top one again. It's got the use of ones in it. I'm a bit obsessed with ones and zeros. I'm obsessed with, because again, it's obvious to us teachers, but to kids.
So on question 24 at the top, they're gonna be like, well, what am I? I mean, we know it's 7m squared.
Exactly. You can imagine it all kicking off there. Yeah, I love it.
This was interesting. This is from Augustus de Morgan. I love him. He's one of my favourite mathematicians. He set up the London Mathematical Society. So he wrote some really clever things. And he says the beginner should write for himself. Everything was always male back then, by the way.
Right.
Such expressions as the following: 4ab squared. Now this is interesting. Actually, I think there's a power. Sorry, power. Oh, there's an index missing there.
Oh yes.
It should say 4a cubed b squared.
Yeah.
And then he's saying that they should write that out as AAABB plus AAABB. And I never would have thought to do that. And I'm not saying we should do that. But this was really interesting. He's writing on how we should teach maths. He writes papers on how to improve math teaching. And he's suggesting that we should be getting our students to write stuff like this out. Now, the last line there is perhaps a bit more like what we do now. But actually, we normally go the other way. We give them the right-hand side and ask them to write the left. And actually, we're not asking them to go in reverse. So I thought that was interesting.
That is interesting.
In Victorian times. This is an explanation from Victorian times. If a quantity be multiplied by itself any number of times, the product is called a power. So remember, it's the product. The whole thing is the power.
Okay, yeah.
So they're on board with me.
Okay, good.
And they're saying that a times a is called the second power of a, and then etc. And they're saying we call it an index or an exponent. And then they have a little note on how we say it. A squared is usually read a squared, a cubed, and then a to the power 4 is read a to the fourth, which used to be the common way of saying it, and then we changed that a bit. And then I love this last bit. When the index is unity, so that's 1, it is omitted, thus we do not write a to the power 1, but simply a. And I love it when they say unity, because that's so lovely.
Nice.
And then straight away they're saying, well, we have to distinguish between a coefficient and an index. So they're talking about the difference between 3a and a cubed. And we know that's the big thing. That's the thing.
Of course.
So this is our big misconception. Students thinking that 3 squared is 6.
Yep.
And students saying that R times R is 2R. These are our misconceptions now, and they've been misconceptions in maths teaching as long as maths teaching has existed.
That, isn't it?
Right from the beginning of maths teaching, they've got the same things wrong. So we're pulling our hair out thinking that we're terrible teachers.
It's fascinating.
It's always been a problem. Yeah, people can't get this right. And the way that they dealt with it then, they started with substitution. So they said, here's an exercise substitution. Some of them are coefficients, some of them are indices. That's how they started.
That's interesting.
So there we have this exercise. This is exercise number 1 in the textbook of algebra.
From the Victorian 10-6.
Victorian 10-6, exactly. And they've got some of them have a coefficient, some have an index, and that's their way into this. That's their way of starting this sort of exploration.
They love a full stop after a question, don't they, as well?
Someone the other day tweeted, I shared a resource and they replied and said, I'm very impressed with the correct use of punctuation. And actually, since then, I've been putting full stops after everything. Yeah, why aren't we putting full stops in our maths? Come on.
A bit confused with the decimal point.
Yeah, I have confused some students recently.
That's probably why.
If you use the equation editor and you do a fraction then a full stop, it does look a bit odd.
Right.
But I don't know, you confuse some decimal points, sorry, that's fine. That's fine.
Okay.
I don't think that's an issue. Because, there's no problem with having a decimal point there anyway.
Okay. All right.
Whatever.
Whatever.
But notice that we have 7 to the power of x. Look at in the bottom one, question 36.
Yes,
so we're straight away putting the substitution and like that. Now I made my own version of this. Okay. It's long. I don't necessarily think anyone should give this. My year 8s did this, and the quick ones did the whole lot.
Okay.
So yes, some people will be like, this is terrible. It's too long, too many questions. But it's exactly what they were doing in Victorian times. Look, I've got the x squared, the x cubed, and the x power 4, and then I've got 2x, 3x, 4x.
Yes.
And then I'm putting the substitution into the index, and then I'm mixing up indices. Now this is not intelligent practice variation theory type stuff because I don't know how to write that stuff, but this is
neither do I, Joe.
This could be turned into that kind of exercise.
Sure.
So
this is kind of what you'd call fluency
practice. This is fluency, yeah, absolutely. And the thing I'm emphasising, and then when I'm going for the answers, I'm emphasising let's not mix up our indices and coefficients.
And again, and the thing is with this, and again, this is me stating the obvious here, but it's not just a case of kids doing these and then the answers go up and then that's job done, because you've got things like I'm looking at question 35 and 38. There's a lovely discussion to be had there compared to 34 and 37. Yeah. Are they the same? Are they different? And so on and so forth. And it's that choice of question that then provides the catalyst for interesting discussions to be had with them.
Yeah.
Love it.
Now, there's all sorts of places. Now, bear in mind, we're just on notation. I haven't started index laws yet.
We haven't, no.
And the thing is that in this presentation, I don't go anywhere near fractional indices or negative indices because there's so much to say. We are just going to look at index laws.
Wow.
So we finished looking at notation. But, there are things we can do even at this point where all we've done is we've done a couple of lessons on notation and, hey, we can do some problem solving already.
Yes.
So all we're doing, this is, I think this is from Colin Foster.
That's nice.
And we're just saying, what's the difference between 3 to the power 4 and 4 to the power 3, which one's bigger? Can we think of anywhere they're the same?
Lovely.
And then maybe this is from there's all sorts of things like this. I mean, that sort of problem you'll find anywhere, but that is arrange the digits to make the sum as large as possible, and that's literally just testing index notation, nothing else.
It's lovely. But again, this is what Colin would call a mathematical etude, where it's you're getting that fluency practice, but you're getting it in a problem-solving context where a bit more's going on. Lovely.
And the other thing that we could do at this point is binary. Now, that's the sort of thing I would put in at the end of the summer term. When people start doing the sort of lessons where they watch a video, at that point, I would go off curriculum and I would teach something like binary. But actually, if you have time, binary is about powers of 2, and it couldn't fit more perfectly into a series of lessons on index notation.
So the kids thinking they're watching Toy Story 4, and in fact, they're coming to your lesson binary.
Yeah, but kids love learning binary, and I don't know. I should find out what they do in computer science on binary, because presumably they do some of it there. But actually, the link to index notation is, given that the whole of binary is once you know your powers of 2, you can write in another language. That's
nice.
Awesome.
That is nice.
Okay, so just finishing off on index notation, this is one that I created. They are problem solving. It's just some fun problems to play with.
That's nice.
And all it involves is index notation. No index laws at all. Some of them, it's really accessible. So every student can start this because the first one is a 9. Could be a -9, so there's a discussion point there, and then there's some interesting ones near the end.
That's nice, that.
And there's some cases where, so for example, that last one, I could put the same number in each and is there anything else I could do? I could have a negative one. There's some nice discussions to be had there.
I like it.
So that was index notation, and you can see that that's a whole load of stuff. That's a lesson or two where we've just looked at the notation itself. Some of that might be in year 7 when you start looking at multiplying in algebra, but then also I sort of did some of this again in year 8 when I was teaching index laws. So I started with, let's make sure we know what an index is before I teach you index laws.
And I think the point there is that, again, for about 13 years of teaching, what you've just done there, that's maybe 10 minutes of my lesson, maybe. And then I dive into this stuff.
Yeah.
Whereas, again, there's so much room to go deep with this kind of stuff. Yeah. There's no need to rush through it all because it's interesting maths and it's important maths.
It is really important because it's fundamental to so much that follows. So what we'll do now is look at index laws. Okay, so index laws are such a wonderful topic, and it's one of those, I call it a performance topic. They always get it in the lesson. Your weaker students will be able to do index laws in the lesson, and it's a case of it's very, we're multiplying the terms, add the indices, here's a load of questions, add the indices. Wow, my students really got this. Hey, you know what? My bottom set did really well on index laws. It's that kind of topic. Yeah. Where actually, to teach this really well, the question is, are they going to remember it, and can they apply it to those kind of unseen problems?
And it's this difference between performance and learning that's so important.
So it's definitely, this is one of the ones where we always feel pretty good at the end of our lessons.
Performance topic. And what's important there, the kids feel pretty good as well, because they think they've got it.
Yeah, absolutely. They feel like this is a topic that's gone well for them.
And the important point there with the index laws is what they're thinking about is how to add two numbers together.
Absolutely. Yeah.
Which anyone can do. Yeah. They're not thinking about the fundamentals of index laws. Fascinating.
So we all know the common misconceptions here, but I'll just quickly mention them.
You say we all know them, but again, as inexperienced teachers, this could be quite a surprise, right?
Yeah, I suppose so.
When you first teach a topic, particularly if you've been used to being good at maths and always been in top sets, first 3 years of my career, I was surprised every day. I was like, what the hell are kids doing here?
You're right, actually. And I think the first one is something I've seen students do on exams, and I've been tearing my hair out because I think I've taught index laws so well that I think they are looking at this and they're thinking 3 times 3 times 3 times 3 times 3 times 3, and then we've got 7 3s there, so it's 3 to the power 7. That's what I'm thinking that's going on in their brain, and then they're writing that down. And I'm saying, well, you didn't do that when they were X's, you didn't change the base.
Yeah, it's hard.
That's really common. Yeah. And the other one that I've seen a fair amount is say we're expanding the bracket. Yes. They're not seeing that as index laws, so they're not seeing that as y squared multiplied by y to the power 3, add the indices, and then multiplying the 2 and the 3.
That's interesting.
I used to teach this in one lesson. I could do index laws in a lesson.
Yeah, why not?
Yeah. In fact, I did this. This was an interview lesson I did for a job that I got. So my interview lesson was, I was told to teach index laws. It was a top set year 8. It was their first time seeing this topic. So I derived multiplication law. I did the understanding bit. I showed them how it works. Yep. I showed them some examples. They did a few. I derived the division law. I showed some examples. They did a few. I derived the power law. I was showing the why.
You're flying.
I did those examples. I gave them an exercise. It was a great exercise. I'm going to show you that exercise. It's really nice. Some of them finished. I gave them extension. Yeah, got the job. And but genuinely, you can teach index laws.
And this is if you want to show rapid progress. This is it, right?
This is ticks all the boxes. Kind of a superficial. This is surface level teaching. I did this, and there's no depth whatsoever there. And this was the exercise I gave them. I'm not criticising this exercise. Okay. There was some lovely stuff. It really pulls out some misconceptions. In fact, I used this year as a consolidation at the end of my kind of week and a half of teaching.
That's nice. I like that.
It's nice. It's Teach It Maths, and it's just a code breaker. Kids love code breakers.
And some unusual questions in there. Yeah. Question 17's nice. Question 19.
I'll tell you the ones they all get wrong.
Oh, yeah, go on.
So these 3.
Oh, okay.
So the first one, as soon as they see a bracket, they start talking about all the operations. And actually, they can do the bracket first. They can expand the bracket here they can't expand the bracket because it's not a plus or a minus, and that's massively confusing because when we teach expanding brackets, we don't talk about the fact that we have two separate terms in the bracket when we expand.
Wow,
that's one term in the bracket.
Yeah, that's interesting.
It's confusing, isn't it? So we don't want them to expand the bracket. We want them to do the brackets first. But when they do that, they're going to get y to the power 26, and they're going to say y to the power 14.
Of course they are.
But then we need them to realise that when they're multiplying, and they're so used to seeing that times sign when you teach index laws, they haven't seen it like this before. Yes. So they're all getting that wrong.
That's a great question.
The next one, they can do the power law bit, no problem. They've got y to the power of 63.
Yes.
But then they're not adding the 1.
No.
Really common problem. And then the one that throws them the most is when you put a non-index laws question in the middle of an index laws exercise, and they have no clue.
And that's so important to do, right? Yeah. This is your non-examples that we've taught through, and we will continue to talk through the Topics in Depth series.
So they're saying, I mean, that's the, to me, that one that's not index laws is the best question on that sheet.
I like that.
So this is how I've always done it. I still do it a bit like this, where we talk about what do I mean by a squared times a cubed.
That's nice.
I mean, it's so easy to explain the concept here.
Yep.
That's why I like index laws. There's no really complex concept. It's kind of clear to us, and it's clear to our students why we've got an a to the power of 5 there. Yeah. So I still do that now. But then when we had all the NECTM sent the exchanges to Shanghai, they came back, and Claire Hill, who was on that exchange, she had seen some non-examples and some examples, and she'd seen all sorts of things on index laws, and she said that, hey, where I'm doing that, they're doing that. So they've got these, again, like we saw earlier, these interesting bases coming in. This is all multiplication law.
Yeah, absolutely.
So we've got a times sign in the first one. We've got the dot. Now, we don't really go near the dot until really university.
Yes.
So we might not do that here. But we've got 3 terms in that 1 second from bottom. Yeah. We've got some algebraic bases. We've got some numerical bases. Yes. So the idea of adding the indices there is way more interesting, and there's a lot more going on than the stuff I've been doing. So then I introduced this, and I've done this a few times now, and I do this, I spend a long time on this one slide. So we're doing the examples and non-examples, but I literally go through each one, and I say, right, the first one, the bases are the same. We're multiplying the terms. We add the indices. And then I write down the answer. And the next one, I say it again. The bases are the same. We're multiplying the terms. So we add the indices.
I like it.
And we don't care that they're decimals. We can add them.
Yep.
The next one, the bases are the same. We're multiplying the terms. So we add the indices. And we talk about that one.
Got
and
it.
Then the next one, bases are the same. Yes. We're multiplying the terms. So that emphasising the fact that we haven't got a times sign, but we are multiplying.
Yeah.
And then obviously you can see that I've got sometimes, like, your 4 to the power of a times 4 to the power of b is 4 to the power of a plus b. And then we've got those kind of unusual bases. We've got 3. And then I'll go over to the other side, and for each one, I'll say, the bases aren't the same. Yes. We are multiplying the terms. We cannot add the indices. So I literally will verbalise every one of them why we are not doing it.
And again, it's the choice of the examples that does this, right?
Yeah. Absolutely. And then what I do with that is I go on to this, which is from your site, from variationtheory.com.
Things are looking up now. Yep.
Yeah, and I will, and we can go through. So there's various ways, and you've got guidance on your site of how to use it, and there's various ways you can do it. You could have choral response. You could pick people to answer them. You could go through them as a class. I could go through them.
Mini whiteboards I often
all
use
sorts
for
of
this.
things. Yep. But this was really interesting because it followed on directly from that.
That's lovely.
And it was, the first one. Yes, and actually what I did was I went round the class and got so no one was getting out of it, and everyone was answering one, and everyone was answering one and having to give a reason and having to verbalise. The bases are the same. We're multiplying the terms. We add the indices. And then if it didn't work, then if it was a no, they had to say where that rule broke.
That's interesting.
So we did that, and that worked really well. I used that this year for the first time following. So I've used that one before, but this time this followed perfectly from that. Back to Victorian times,
yeah. Let's do it.
So back in the 1800s, notice how they're explaining index laws here, but they then introduced the coefficients. Now we don't have coefficients here, and the thing is that does get a bit confusing for them, because now they're sort of saying, well, the base isn't the same.
Yes.
It's like, well, the bases are the same, but this time we've got a coefficient.
Yes.
So here, like if you look at the example at the bottom, the bases are the same because the bases are the A bit, and the 5 and the 7 are just coefficients. So it does get quite complex.
And kids need to know about order of operations to fully know what's going on there.
And so the way that one is written out, I mean, that's what we need to be doing. We need to be talking about the 5 times 7 and the 8.
Yeah, that's nice, that.
Something else that they then bring in is, and now this is interesting because they've brought in the 3 terms, but look at how they've written. They've done the first 2. I know you can't really read the numbers because it's not a great copy, but they've done the first 2, and they've written the plus in the index, and I don't normally do that.
No, that's interesting.
And then they've written their workings out, whereas I would just write the answer there. Yeah, so I thought that was interesting, the sort of writing out of the workings a bit sort of clearer, and writing that adding up in the index.
And what are they chatting about here? It's called the continued product. Are you using
we don't call it that anymore. There's a lot of vocabulary that's died out. It's just the product of 3 or more expressions, and actually they use that quite a lot, and these things just disappear. Really odd.
Interesting.
So they've introduced at least, more than 2 terms. So they've introduced coefficient, they've introduced more than 2 terms. Then they've got their shed loads of practice.
Oh,
so
yes,
our
they love that.
Our fluency. Totally different to the exercise we see today because they haven't put the times sign in, they haven't put multiplication sign, they just said multiply together and they've got an and.
They've got the full stop in there though.
They've got the full stops, yeah. And then notice down the bottom, we're into, that's going to have to be expanding brackets at the bottom. Because we're multiplying, 3 terms by a term, and that means we're going to have to, it's not quite as straightforward. So we wouldn't do that now. And I'm not suggesting we want to do that now. Yeah.
Sure.
So that bit at the bottom is perhaps a bit different to how we would currently start, because I might not have taught expanding brackets, so I don't really want to go there at this point.
Be a good recap exercise though for year 11s or something like that,
absolutely,
right?
Yeah. And then we could put fractional, negative, and algebraic indices in at any point, because like for example that question 1, we know they want to add the 2 and the 5 to get the 7 as the index.
Yeah.
But we could have a 1.5 and a 3.5, and there's no reason not to.
Absolutely.
And in fact, also no reason not to have a calculator on the desk. Unless we're specifically wanting to practice arithmetic, why not?
Yes.
Yeah. So we shouldn't let the adding slow us down here because it's algebra. So we're not cheating with the calculator because it's algebra. So there's all sorts we can do there. They also, in Victorian times, something I really like was they took every single opportunity to bring negatives in. Oh. And we don't do that enough. Well, I certainly don't do it enough
me
now.
Neither.
So straight away, now this is no different. It's index laws with coefficients, but they're making those coefficients negative. And they do this a lot. Every time they can bring in negatives. So this is another exercise, which is really similar to previous exercise. And the only difference is, hey, you need to know how to multiply a negative by a positive or a negative by a negative. So I thought that's quite nice that we just don't bring that in as much. The opportunities to interleave negatives are probably in every single topic we teach.
Absolutely, and it's one of the highest value skills around because it comes into everything.
So there's an exercise from variationtheory.com.
Another good shout out for that, Jo.
And I tell you what, this is really interesting because we've got those negatives in the indices.
Yes.
So again, when I gave this to my students, I didn't let them use a calculator because I wanted them to practice. I wanted them to know what 3 plus negative 10 is.
Yes.
So I didn't let them use one there. But this is another really good example of different stuff going on. So we're not just saying add the 3 and the 4, add the 3 and the 5, blah, it's boring. We've got those negatives. And then if you look down at question 15 and 16, then we've got some algebra up there. So it's a case of, do they know how to add 5y and negative 4y? And
when I've done this exact one with kids, and between 8 and 9 it often kicks off when that coefficient starts to appear there. It starts to throw them, and it's that crossover between when something. I mean, that's the whole idea of behind these sequences. When just that one thing changes, what impact's that going to have on your answer? Nice.
Yeah, so I've used that, and that's a brilliant one. And so that was, notice how that was, I've just been talking about the multiplication law. And whereas previously I've done them all in one lesson, I've maybe done 1 or 2 lessons there, perhaps 2 lessons just on one law. So and
again, you could boil it down to just add the indices together, but it's so much more than that.
There's so much we can do. That's so I reckon, especially when you bring the coefficients in, that's 2 or 3 lessons there. I've gone for power law next, not division law.
Oh, controversial.
Because I see the power law as just an extension of the multiplication law. It follows on. Because if you look at what we're doing here, a squared cubed is a squared times a squared times a squared, and then we're back to multiplication law, we're adding the indices. Okay. So we could just see it. I don't think it really matters. I tried it this year, I don't think it made much difference, but I did do power law. But
you're right, though, by default I always do that last, and I've never thought
we all have this weird order with the 3 of them, and I don't know why.
Yeah, that's interesting.
So I did that. This is from a modern textbook. This is a textbook from a couple of years ago. And that is, notice how question 14, D and E are the exact same question. So that's not great. So that means that we actually have...
Oh, literally the same.
Literally the same question. So we have 5 questions, because there's a duplicate, 5 questions without coefficients, and then we have 6 questions with coefficients. And
done and dusted.
I mean, assuming that they don't think this is sufficient. I mean, it's a textbook that has the whole of GCSE in.
Yeah.
Whereas it used to be you'd have a textbook that had some algebra in.
Yes.
And we've got too much stuff in our textbooks. So compare that to that.
Wow.
And that's from the 50s. That's not even Victorian times.
Yeah.
In the 50s, they had that many questions. I'm not suggesting we have to do that many questions now. We're into the hundreds there. But there's some better quality questions in there.
That's interesting.
Okay. And if you look at that one, 2x squared plus 3x all squared, that is power law. So use your power law on the 3x all squared and you get 9x squared.
Yes,
and then there's some simplifying because you're then adding it to it squared and you get 11x squared.
And it goes back to, again, we said at the start, like if you look at 14 and 15, the newer version, what are kids thinking about there? Are they thinking about indices or are they just multiplying those numbers together?
Absolutely. I mean, question 100 there is bringing in the power law and the multiplication law together. Yeah. So there's some really great stuff there. Lovely I actually turned that into this. I basically borrowed those questions, typed them up, and did this with my year 8s this year. Nice. So it was, it started off. This was all I gave them this was their fluency practice on power law. So it wasn't a separate one where I gave them questions like 1 and 2.
Yes.
This was their practice.
And it's important, like 1 and 2 are in there to ease them into it and stuff, but then you want them thinking about other things. Lovely.
Yeah. And they do the index does. I mean, actually, I tell you where they struggled was question 7 because I hadn't shown them one like that.
Ah, yes, of course.
So that was where I had the most hands up, which surprised me because that's relatively straightforward to us, but that was new to them.
It's classic curse of knowledge, isn't it? And my rule is if there's any doubt, stick a question in on it.
Yeah. I'm not going to talk about change of base because I kind of feel like I need an hour on that. It's a massive thing. I find it really hard to teach it very well. I used some stuff from variationtheory.com this year and it really helped because it really sort of broke it down into stages.
We could tease the viewer. We might be back with one of those another time.
Well,
who knows?
Change of base I think is something that I want to go off and spend a long time thinking about how to teach it because I tried it this year with my year 8s and I went too fast on it and they just couldn't do it. And like I say, normally I do it with year 10, year 11.
It's massive for A-level.
I mean, if you look at that question there, which I've used at A-level many times, as like an introduction in sort of lesson 2 of A-level. They need to put them all as a base 2. So write them all as powers of 2, then multiply some fractions, and then put the fractions in order. Yeah. So I always use that one with A-level, and it's basic skills, and they don't even need the fraction skills at A-level anymore because it's all calculator. But that changing the base thing is, to me, it's complex and fundamental and lovely, and I love change of base. But students who are novice learners to indices, that's a step too far in some cases. So finishing off with the index laws, we've got division law.
Nice.
So we've got, that's interesting from Victorian times because we're doing, notice how they've written it out, 27A to power 5. They love
a bit of that, don't they?
And they're writing it all out.
It helps though, it really helps.
I think it does, yeah. And notice how they've written the subtraction in the index there.
Yes.
Which again, something I've never done, actually being really explicit about that subtraction.
That is nice.
And then there's their practice, absolutely tons of it, and a really nice range of questions. So again, something that's changed a lot in how we teach at the moment.
And again, it's just getting kids familiar with weird looking things, isn't it? It's
nice. They've got all these weird fractions that, question 43, half A divided by half A. It's really random. Like, why is that in there?
I like it.
And then if you look at, again, if we look at textbooks from foreign countries, now, this is confusing to us because they use a ratio symbol to mean division there. So that is their division symbol. Okay. But notice how they have the division symbols, but they also have the fraction as well. So we need our students to know that divisions and fractions are equivalent. And they've got all sorts of things happening here. Nice. There's some really good stuff there.
I noticed how you subtly avoided naming the countries you can't say.
Yeah, I did try earlier.
That's good.
So we need our students to see a range of things, including fractions, division symbols. Sometimes we've got algebra in the index, so we're just subtracting algebraically. Sometimes we've got numbers in the index. Sometimes we have numbers in the base. Sometimes we have algebra in the base. Wow. We have all these things, and like to say that we can teach that in 5 minutes when there's all this stuff that we can explore.
Yes.
And really...
and again, the point there, again, it's worth going back to with all these topic in depth. It's not wasted time doing this because the kids are understanding this topic better, but they're also interleaving in all the other topics, so they're understanding that better. Yes. So it's time really well spent, I think, on this.
And I think, so there's so much we can do on index laws, and if they get into the point where they can do these really sort of unusual, we're putting algebra in the index and all that sort of thing, then they know they get it, but we have to see they can get it with all these variations.
Yes.
Okay. That's it for index laws, and now we're going to have a look at some resources. Looking at some resources and activities for teaching index laws, there are hundreds and they're all wonderful. I'm just going to show you some of my favourites.
Okay.
Variationtheory.com. So, I've mentioned
slip you the fiver later.
I've mentioned it a couple of times. Really, really good questions. This is the power law. There's no coefficients in here, but notice how there's a mixture of number and algebra in the indices and some fractions and some negatives.
I wrote that one.
Oh, did you?
Yeah.
Really great questions.
Classic.
Yeah. Really great. I love this from Yummy Maths. This is awesome. Ooh. So this is really fun. You give them all the powers of 2. You talk about how they're the powers of 2.
Nice.
And then you say, well, how are we going to do 32 times 16 without a
Wow.
calculator? Well, that's 2 to the power of 5 times 2 to the power of 4, which is 2 to the power of
That
9,
is good.
which is 512.
Yeah, I
and
like
that
that.
is fun. And my year 8s actually loved this.
There's some big numbers there. That's lovely.
They genuinely found this really fun. So yeah, question 6, 2 to the power of 30 divided by 2 to the power of 6, and then you can get the answer from the table.
I'll give you
That's
that.
really fun.
Good old you and me maths.
MathsPad have tons of lovely stuff. I mean, this one you're using your inequality symbols, and this one's actually just about index notation. This isn't index laws, but do we know what 3 squared is? Do we know what 2 cubed is? And can we get that right symbol? Because we're interleaving those symbols.
Nice.
This one's from an OUP textbook, but it's a really nice example of just a slightly more interesting way of asking. It's a bit of problem solving here. The 3 terms on each edge have to multiply to give 60. So you just need to think about your multiplication law. So in that bottom right corner, what coefficient am I going to need and what index am I going to need in order to get...
Just get 60. That's good.
That's quite a tricky one. It's lovely though. Teach It Maths has this great crossword which is to do with using a calculator. So if you want your students to practice using that key on the calculator, that power key,
which we assume they can use perfectly competently.
There's a number of keys. We've got the root keys. We've got the, how do we do a cube root? How do we do a 5th root? How do we do a power of 20?
Yeah.
With all those keys we need to teach them. We can use an emulator for that, and then we can get them doing this really nice activity. Finally, there is tons of problem solving we can do here. So absolutely loads of stuff we can do in terms of write as many expressions as you can that are equal to 8 but involve indices. So we can play around with that. And then this is pretty tricky. If 3 to the power of 100 is denoted by m, how do we write 3 to the power of 101? Now this is pretty tricky, and this is real kind of extension problem solving stuff. I would normally give that at A level. And that takes a bit of thinking. So there's some lovely stuff there. Now notice how we're looking at all these resources. We haven't gone near negative and fractional indices. I haven't mentioned the 0 index, which is a really nice opportunity for spotting patterns and there's all sorts of things to do there. So there's all this stuff we could do. And how many lessons should we spend on index laws? I don't have an answer for that, but the answer is lots of lessons, lots and lots of lessons, going into depth and getting to the point where we can do anything on index laws.
Because it goes back to the point of this whole series is that, again, we shouldn't think in terms of exams, but if we're thinking practically, we need to prepare the kids for the unpredictable. Exams, by their very nature, have to be unpredictable. It's one of the guidelines given to examiners when they're creating the AO3 questions. They've got to be unusual. So we can't prepare kids for everything. We can't have shown them every type of question they're going to get on an exam. So our only option is to teach in depth, is to prepare them to be the flexible, problem-solving mathematicians that we need them to be.
Absolutely.
And the only way to do that is to teach the topics in depth.
The surface of everything, they're never going to get there.
No.
So even if people watching this haven't learned anything new about indices, I hope that the message I'm giving is that when we're planning a topic, we need to plan it in depth. We need to research it and really think about what is my teaching going to look like if I actually teach this really, really properly, like really go into that detail. And then when we deliver those lessons, we actually teach it in depth. So we spend time on things when we can, and that's the challenge for teachers today.
So the question to listeners there is, how does your teaching of indices fit into this? Do you use some of the resources that Jo uses? Do you use them in the same way? Do you use them in different ways? Do you have some of your own favourite resources that you like to use, and how would they fit into this bundle, this approach, this sequence that Jo's been talking about? I thought that was absolutely fascinating, and we'll be back with more Topic in Depth, kindly supported by the TES, in the near future. Bye-bye.